come we are seeing such a rare giant object as the third object from interstellar space. And it also looks anomalous in other ways.
Scientists have just dropped an official confirmation of artificial lights on 3I Atlas, a mysterious interstellar object hurtling through our solar system. This isn't just another space discovery. It's a moment that challenges everything we thought we knew about life beyond Earth. Per time, the universe reminds us that we are not the center of everything. It does this by tossing something unexpected into our cosmic neighborhood. In 2017, it was Oumuamua, the first recognized interstellar object. In 2019, it was Borisov, a comet from another star system. Now, in 2025, astronomers are tracking another, 3I Atlas. The discovery was made in July 2025 by the Atlas survey in Chile. At first glance, it looked like a faint comet, but calculations of its orbit quickly revealed that this object isn't bound to our sun. Instead, it's traveling on a hyperbolic trajectory, which means it came from outside our solar system. Looking from all indications, it will eventually head back into deep interstellar space, making it the third confirmed interstellar visitor ever spotted. Already, that fact alone is incredible, because out of the billions of objects wandering the galaxy, only 3 have ever been confirmed to pass through our system and identified as such. Surprisingly, each one has been strange in its own way. Oumuamua had a bizarre elongated shape and unexplained acceleration. Borisov looked more like a typical comet, but its chemical makeup hinted at materials from another star system. Now 3I Atlas has arrived, carrying mysteries of its own. NASA and ESA quickly confirmed that 3I Atlas poses no threat to Earth. Its closest approach to our planet will be about 1.8 astronomical units, that is around 270 million kilometers away. To put that into perspective, that's farther than the distance from Earth to the Sun, so apparently no danger. But if safety isn't the issue, then why is this object making headlines? Its behavior doesn't quite line up with what scientists expect from an ordinary comet.
Because it's the third time we've ever seen an interstellar object. And interstellar doesn't just mean Matthew McConaughey, it means something not from our solar system. It's interstellar, it's between suns.
Comets are, in a sense, frozen time capsules. They spend most of their lives in the deep cold of space, far from the sun. When one swings inward, solar heat makes its icy surface sublimate. That's when solids turn directly into gas. This releases both vapor and dust, creating the coma and tail we associate with comets. Because they don't produce their own energy, comets shine only by reflecting sunlight. Their glow fades in a predictable pattern as you move away from the core. But when astronomers pointed the Hubble Space Telescope at 3I Atlas, the light they recorded didn't follow these usual rules. The brightness dropped off much more steeply than expected. Instead of a smooth, gradual decline, it seemed sharper, as if the glow wasn't purely sunlight bouncing off dust. This caught the attention of Avi Loeb, a well-known Harvard astrophysicist, and his collaborator, Eric Hresdes. They argued that the brightness profile could look more like emission from within the object rather than reflection from without. If that were true, it would mean that 3I Atlas isn't just passively shining, it might be actively glowing. Now, before anyone jumps to conclusions, let's be clear. This idea is highly speculative, and the mainstream scientific community has not embraced it. Most researchers still lean toward natural explanations. One reason is that the James Webb Space Telescope had already detected carbon dioxide coming from the comet, which is exactly what you would expect from subliminating ices. That strongly supports a natural origin. So why do people still find this light puzzling? Well, it's because it doesn't fit perfectly into existing models. The glow seems asymmetric, stronger toward the sun in some images, and weaker than expected in forming a tail. These quirks don't demand an artificial explanation, but they do force scientists to refine their understanding of cometary physics. In science, anomalies are gold. They either reveal gaps in our models, or in rare cases, point to something genuinely new. Loeb's suggestion that the glow could be artificial is not the majority view, but it keeps the conversation sharp. By daring to suggest the extraordinary, he pushes the community to tighten its arguments and explore every natural option more carefully. As if the brightness isn't enough, the orbit of 3I Atlas had also sparked debate. Interstellar objects usually barrel into our solar system at random angles, cutting across the planetary plane. That's exactly what Oumuamua did, but 3I Atlas is different. Its path is unusually aligned with the ecliptic, the same flat plane where most planets orbit. Think of it like watching traffic on a highway. If most cars enter from random dirt roads, you'd expect them to swerve, cut across lanes, and merge at odd angles. But now imagine a car coming in smoothly, perfectly aligned with the flow, almost as if it knew exactly how to join the traffic. That's exactly how 3I Atlas looks compared to the solar system's layout. To some astronomers, that alignment is just a coincidence. Rare events happen, and given enough time, unlikely things will also be observed. But Avi Loeb sees it differently. To him, this alignment is suspicious, another reason not to dismiss artificial origins too quickly. Here's the catch. The data is still limited. Interstellar objects are faint, fast, and fleeting. We only get a short window to observe them before they fade back into the black. So while the orbit looks neat, scientists caution against overinterpreting it. Biases in detection could also make it seem more aligned than it really is. What we do know is that 3I Atlas reached perihelion, its closest approach to the Sun, in late October 2025. Unfortunately, that timing placed it close to the Sun in our skies, making ground-based observations difficult. Space telescopes like Hubble and Webb have helped fill in the gap, but much about its path and behavior remains to be nailed down. So where does that leave us? Right in the middle of one of the most fascinating astronomical puzzles of our time. On one side, we have solid evidence that 3I Atlas is a comet. Its chemistry shows carbon dioxide and nickel, consistent with icy material from beyond the solar system. It behaves, at least partly, like other comets we've studied. On the other side, its light profile and orbital alignment keep raising eyebrows. They don't fit neatly into the models, which leaves room for speculation. Avi Loeb's artificial light hypothesis may be provocative, but it forces scientists to test every assumption to make sure no natural explanation is overlooked. The truth is, anomalies like these are what science thrives on. They push boundaries. They remind us that we don't have all the answers. Oumuamua baffled us with its strange acceleration and shape. Borisov taught us about the chemistry of other star systems, and now Atlas is teaching us that interstellar comets may be more varied than we imagined. What happens next depends on ongoing observations. Even though perihelion has passed, the comet's outbound journey will still be visible to some spacecraft and telescopes. NASA's Juno mission orbiting Jupiter might even catch a glimpse. Meanwhile, astronomers around the world will continue crunching the data, testing whether 3I Atlas can be fully explained as a natural comet. If it can, our understanding of cometary physics will expand in exciting ways. And if it can't, then we may be standing at the edge of something extraordinary, perhaps even the first sign of technology from another civilization. Either way, the story of 3I Atlas proves one thing: the universe still knows how to surprise us.